Let's jump straight in. Say you have a customers table and an orders table. Walk me through the difference between an inner join, a left join, and a full outer join on those two tables, and tell me when you'd actually reach for each one.
Sure. The easiest way I think about it is what happens to unmatched rows. With an inner join, you only get rows where the join condition matches on both sides. So only customers who have at least one order would show up. A left join keeps every row from the left table, customers in this case, and fills in nulls for the order columns when there's no match. So Dana, who's never ordered, still appears, just with nulls. Full outer join is the union of both sides, all customers and all orders, with nulls wherever one side has no counterpart. In practice, I reach for left join probably 80% of the time, whenever I want to keep all my base records regardless of whether they've done something. Inner join is for when I genuinely only care about the intersection, and full outer tends to show up for data quality checks, like finding records that exist in one system but not the other.
Good. Quick follow-up. If I write left join but then put where orders dot status equals paid in the where clause, what happens?
That silently turns your left join into an inner join. The reason is SQL's execution order. The from and join run first, which produces those null rows for unmatched customers. Then the where clause fires, and for any customer with no orders, orders.status is null. Null equals paid evaluates to unknown, which is treated as false, so those rows get eliminated. You end up keeping only the matched rows, which is exactly inner join behavior. The fix is to move that filter into the on clause, so it becomes part of the join condition rather than a post-join filter. That way, customers with no paid orders still appear with nulls.
Nice, that's a trap a lot of people miss. Moving on, what's the difference between where and having, and when is having not just optional but actually required?
The core difference is timing, where filters individual rows before any grouping happens. Having filters groups after group by has already been evaluated. So, if I want to look at only orders from this year, that goes in where it's a row-level filter and it runs early, which is also better for performance because the engine skips those rows before doing the expensive grouping work. But if I want to keep only customers who placed more than 5 orders, I can't express that in where, because count of orders doesn't exist yet at that stage. The engine would throw an error. That filter has to go in having, because at that point, the groups exist and the aggregate values are available. So having is required anytime your filter condition references an aggregate function like count, sum, or average.
Straightforward. Let me shift gears slightly. What is a primary key, and how is it different from a foreign key?
A primary key uniquely identifies each row in a table. It has 2 guarantees. The values must be unique across all rows, and they can never be null. The database automatically creates a unique index on it. A foreign key lives in a child table and references the primary key of a parent table. Its job is referential integrity. So in our customers and orders example, orders.customer_ID is a foreign key referencing customers.id. That means you can't insert an order for a customer who doesn't exist, and you can't delete a customer who still has orders, unless you've defined a cascade rule. One thing worth flagging for analytical work. Warehouse like BigQuery and Snowflake technically accept foreign key declarations, but they don't actually enforce them at right time. So in a warehouse setting, referential integrity is something you have to validate in your ETL pipeline, not something you can rely on the database to catch for you.
Good awareness. Now a visualization question. A marketing manager asks you to show monthly revenue trend, a breakdown of revenue by product category, and whether ad spend correlates with sales. What chart types would you use for each, and why?
I'd think about each one in terms of what question the viewer needs to answer. For monthly revenue trend, that's change over continuous order time. So a line chart is the right call. The connected line encodes continuity and makes the direction of movement obvious. For revenue by product category, that's a comparison of magnitudes across discrete groups. So I'd use a horizontal bar chart sorted descending. It makes it easy to rank categories and read the labels without craning your neck. For the ad spend versus sales question, that's a relationship between two numeric variables. So I'd go with a scatter plot, potentially with a regression line if we want to highlight the direction of the correlation. The thing I'd want to avoid is using a line chart for the category breakdown just because there's a date somewhere in the data. Lines imply continuity between points. If the categories don't have a natural ordering where intermediate values would make sense, a bar is clearer.
Good reasoning. Quick one. When should you report median instead of mean for a metric, and what's the formal way to think about robustness?
The intuition is that mean is pulled by extreme values. Median isn't. If you're reporting average order value and you have a few massive B2B orders, the mean will look much higher than what a typical customer spends, which can mislead product or marketing decisions. The median, which only cares about rank, tells you what the middle customer actually experiences. The formal framing is breakdown point. How much of your data can be contaminated or arbitrarily corrupted before the estimator goes completely haywire. The mean's breakdown point is essentially zero. One single infinite value, and your mean is meaningless. The median's breakdown point is 50%, meaning half the data could be garbage, and the median would still give you a sensible answer. That's what makes it robust. I'd still flag one nuance though. If the business question is about expected revenue, like forecasting total revenue, the mean is actually the right number, even if the distribution is skewed, because you're computing an expectation. Robustness is about estimating the typical experience, not always the better answer.
Useful nuance. Here's a thought question. You're handed a user's table with an email column, and you suspect there are duplicate email addresses. How would you find them in SQL, and how would you decide which one to keep?
First, I'd clarify what makes two rows a duplicate. Is it just the email, or does the combination of email and name also have to match? Assuming it's email alone. To find duplicates, I'd group by email and use having count star greater than 1, which surfaces every email that appears more than once. That's the diagnostic step. To actually decide which row to keep, I'd use row number partitioned by email and ordered by the ID ascending. So row number 1 is the earliest insert. Then keep only where row number equals 1 and delete the rest. I always do the identification step first and look at which rows would be marked before touching anything. One subtle point. You can't write where row number greater than 1 in the same query that computes the row number, because window functions run after where. In SQL's execution order, you have to wrap it in ACTE or subquery and filter on the result.
Good recall on the execution order trap. Last one for this round. I'm going to describe a funnel and I want you to tell me what you notice. Sign up page, 10,000 visitors. Email verification, 6,000 completed. Onboarding setup, 2,000 completed. First core action, 800 do it. What stands out?
The biggest drop by far is between email verification and onboarding setup. You go from 6,000 to 2,000, which is a 67% drop-off at that single step. That's where I'd focus first. The email to onboarding step is losing 4,000 people, which is more than the total who even reached the first core action. The step from sign-up to verification is a 40% drop, which is meaningful but more typical. Some users are just kicking the tires. And then onboarding to first action is another 60% drop, which also warrants attention. But the onboarding step is the bigger lever because it's upstream and the volume is higher. Practically, I'd want to dig into the onboarding step. Is this a UX friction problem? Is it a certain device or platform? Is it new users versus returning? And has this rate changed over time, or is this baseline?
Nice structured thinking. Round 2. We'll go deeper. I want you to write or walk me through a query that computes a running total of daily sales partitioned by customer. And tell me what the frame clause is doing and what goes wrong if you omit it.
Sure. The pattern is sum of amount over, then partition by customer underscore ID. So the running total resets for each customer, order by order date, and then the frame clause, rows between unbounded preceding and current row. The partition by is what scopes each running total to one customer. The order by inside the window determines the direction of accumulation. The frame clause is where it gets subtle. Rows between unbounded preceding and current row means, for each physical row, sum everything from the start of that customer's partition up to and including this exact row. That gives you the classic staircase, 100, 150, 230, and so on. If you omit the frame clause, the database defaults to range between unbounded preceding and current row. Range operates on logical values, not physical rows. So if two orders share the same date, range treats them as peers, and both get the same running total, which includes each other's amounts. You end up with the total for all tied rows being shown on both rows simultaneously, which looks like the total is stalling rather than accumulating. That's a silent correctness bug. I always write the rows version explicitly to make the intent unambiguous.
Good. How would you modify that to get a 7-day moving average instead of a running total?
Instead of sum, use average and change the frame to rows between 6 preceding and current row. That gives you a window of 7 rows total, the current row plus 6 before it. For dates at the start of the partition, where fewer than 7 rows exist, the window just uses however many are available, which is usually the right behavior. If you wanted to enforce a strict 7-day calendar window, you'd need range between interval 6 days preceding and current row. But that syntax varies by database and can be slower.
Let's say a customer success team has asked you to build them a dashboard. They manage about 200 enterprise accounts. What KPIs would you include, and how would you decide what goes on the main view versus a drill down?
I'd start by asking what decision this team makes daily. Usually it's, which accounts need attention right now, and is the overall book of business trending well or not? So I'd organize the main view around those two questions. At the top, I'd put the health summary, overall renewal rate versus target, number of accounts flagged as at risk, and net revenue retention. Then below that, an account level table sorted by risk score, so the team can immediately see who to call. On the main view, I'd aim for 5 to 9 metrics max. Anything beyond that becomes a data dump and people stop reading it. Consistent scales matter too. If you're comparing renewal rates across account managers, all those charts need the same y-axis range, or you get misleading comparisons. Drill downs would hold the per account detail, feature adoption breakdown, support ticket history, last login trend, health score components. That layer is for account managers who are already investigating a specific account. One thing I'd include on every KPI tile is context. A number without a trend line or a comparison to target is just a data point, not information.
What refresh cadence would you choose for this dashboard, and does it matter?
It matters quite a bit. Customer success is a daily action workflow. Account managers check it in the morning to plan their outreach. So daily refresh makes sense for the risk scores and account level status. The higher level metrics like renewal rate and net revenue retention move slowly enough that weekly is fine, and refreshing those daily just adds noise. I'd want to match the granularity of the displayed data to the decision cadence. Showing daily noise on a metric the team can only act on weekly just creates anxiety without actionability.
Okay. Your weekly active users metric dropped 12% week over week. No one on the team flagged a product change. How do you investigate?
My first move is to figure out whether this is real or an artifact. I'd check the data pipeline first. Was there an ingestion delay, a logging outage, or a date boundary issue that made last week's numbers look artificially low? That's caught me before. Assuming the data is clean, I'd split the investigation into two buckets: acquisition and activation. Did fewer new users come in, or did existing users stop engaging? I'd look at new signups week over week and at returning user activity separately. Then I'd segment the drop by platform, by geography, by user cohort, by feature usage. Drops that are concentrated in one segment point toward a specific cause. Drops that are uniform across everything often point to something systemic, like a change in how we're calculating the metric. I'd also look at whether other adjacent metrics moved: session length, correction completions, notification delivery rates. If WEU dropped, but everything else is flat, that's strange. If the whole engagement funnel compressed, something higher up in the user journey broke.
Let's say you segment it and find the drop is entirely on Android. iOS is flat. What now?
That's a useful signal. The next questions are, did anything happen to the Android app recently? A build, a permission change, a third-party library update? And when exactly did the Android drop start? I'd pull the Android crash rate and the Android session start success rate for that period. If crashes spiked on the same date the WAU dropped, that's likely the cause. I'd also check if it's all Android versions or a specific one, because that narrows whether it's an OS-level compatibility issue or something else. I'd want to timestamp the drop as precisely as possible and then diff what changed on Android in that window.
Good systematic approach. A/B test question. You ran a test on your checkout flow. Treatment had a conversion rate of 4.3%, control had 4%, p-value is 0.03, and the experiment ran for 10 days on 50,000 users. Would you ship it?
The p-value is below 0.05, so the result clears the significance threshold, and the absolute lift is 0.3 percentage points, which is a 7.5% relative improvement on conversion. That's economically meaningful for most checkout flows. But before I say ship, I have a few questions. First, did we pre-register an MDE, and did this experiment have enough power to detect that lift reliably? A 10-day runtime on 50,000 users is usually enough for a checkout metric with this much traffic. But I'd want to confirm we calculated the sample size beforehand, rather than stopped early when the result turned significant. Stopping early inflates false positives. Second, I checked the guardrail metrics. Did average order value hold? Did return rates or support tickets move? Did page load time regress? A conversion lift that comes at the cost of latency or order quality isn't a win. Third, I'd look at whether the lift is consistent across segments: mobile versus desktop, new versus returning users. If the lift is entirely driven by one small segment, I'd want to understand why before shipping to everyone. If all of those check out, yes, I'd recommend shipping.
What if I told you we actually checked results every day and stopped when P hit 0.03 on day 10?
That's a problem. And honestly, that changes my recommendation to hold. What you're describing is the peaking problem. Every time you check an in-progress experiment and act on the p-value, you're running an implicit multiple comparisons test. Over 10 daily checks at alpha 0.05, the probability of seeing at least one false positive can climb well above 5%. The experiment effectively stopped at the first favorable result rather than at a pre-specified endpoint. To be confident in this result, I'd want to either rerun the experiment to a fixed horizon determined by the power calculation upfront, or apply a sequential testing framework like alpha spending if we genuinely need to monitor continuously. The result as described doesn't give us reliable inference.
Good catch. Let's talk about data quality. You pull a dataset for analysis and find it has null values in the revenue column, some rows where user age is 999, and duplicate transaction IDs. Walk me through how you'd handle each.
I treat each one differently because the right response depends on the cause, not just how extreme the value looks. For null revenue, first I'd understand whether null means the transaction genuinely had zero revenue, or whether it means the value wasn't captured. Those are very different. If null means zero, I can coalesce it. If it means unknown, I'd flag those rows separately rather than imputing, because including unknown revenue in a sum distorts the analysis. For age of 999, that's almost certainly a placeholder or system error, probably a default value that got committed to the database. I'd verify by checking the frequency and distribution of that value. Then either correct it if the real value is recoverable from another source or exclude and document it. For duplicate transaction IDs, I'd first check whether it's a true duplicate or a genuine many-to-one pattern, like a transaction being split across multiple rows for line items. If it's a true duplicate, I'd use row number to identify and deduplicate, keeping the earliest row or the most complete one depending on the business rule. I'd always document what I did and why, because these decisions affect the numbers downstream and other analysts need to know.
Last one for round 2. You've just finished an analysis showing that a feature the VP of product loves isn't actually driving the retention improvement they thought it was. How do you communicate that finding?
I'd lead with the business implication, not the methodology. Something like, the data suggests the feature isn't the driver we thought, and here's what that means for how we prioritize the roadmap. I'd set up a one-on-one before dropping it in a Slack message or a large meeting. A finding like this deserves a conversation, not a surprise. In the meeting, I'd start by showing the analysis. But before that, I'd make sure I understood the VP's original hypothesis. Because sometimes, what looks like contradicting evidence is actually answering a slightly different question than the one they had. I'd show the data transparently, including what I could and couldn't rule out. Maybe the feature did improve something else, or maybe we need a longer measurement window. I'd also come prepared with the proposed next step, because landing a negative finding without a path forward just creates frustration. And if after the conversation the VP decides to continue investing in the feature for qualitative reasons I can't measure, I'd respect that call. My job is to make sure they're making it with accurate information, not to be right.
All right, round 3. These are the harder ones. Revenue is down 8% month over month. The CEO wants an explanation in the next 2 hours. Talk me through exactly how you'd structure your investigation.
First thing I do is sanity check the number itself. Is this a reporting artifact? A pipeline delay? A date filter off by a day? A currency conversion issue? Or is it real? I've been burned before by spending an hour investigating a drop that turned out to be an ingestion lag. Assuming it's real, I'd break revenue down into its components. Revenue equals number of transactions multiplied by average transaction value. Did transaction volume fall? Did average value fall? Or both? Those have different causes and different fixes. Then I'd segment along 3 axes: product line, geography, and customer segment. New versus returning, free versus paid tier. A drop concentrated in one segment is much more actionable than a uniform drop. Parallel to that, I'd look at whether anything happened on the supply side. A pricing change, a promo that ended, a major customer churning, or an outage that disrupted checkouts on specific dates. I'd pull the daily revenue trend within the month to see if the drop was gradual or whether it inflected sharply on a specific date. A sharp inflection on a specific date almost always points to an event. A deploy, a campaign ending, a competitor action. A gradual slope points toward a trend. With 2 hours, I'd prioritize getting a clear answer on whether volume or value drove it, and which segment is most affected. Then I'd present those findings with the confidence level and what's still unknown.
Let's say you segment and find that revenue is up in every individual product line, but down overall. How is that possible and what does it tell you?
That's a Simpson's paradox situation. Revenue can be up within every product line, but down in aggregate if the mix shifted toward low revenue product lines. Concretely, if your enterprise product, which drives most of the revenue, shrank as a share of total transactions, While your smaller, lower value product grew, the aggregate could fall even if each product individually improved. The aggregate is a weighted average, and when the weights change, the average moves even if every component held steady. The diagnostic question is, what changed in the revenue mix between the 2 months? That's what the aggregate number is actually reflecting, not a performance decline within any individual line. This is why I always check composition when I'm looking at aggregate changes. It's one of the most common ways a headline metric tells a misleading story.
How would you verify your mix shift hypothesis before presenting it?
I'd compute the revenue mix by product line for both months. What percent of total revenue came from each product and show the shift explicitly. Then I'd do a counterfactual. Apply this month's volume at last month's product mix and see what the aggregate would have been. If that counterfactual is close to last month's revenue number, the mix shift explains most of the gap. I'd also check whether the mix shift itself is expected. Was there a change in marketing spend favoring the smaller product, a seasonal pattern, or something in the sales funnel? Because that tells me whether it's a concern or just the expected consequence of an intentional decision. I'd present both the observed and counterfactual numbers together so the audience can see the mechanics, not just the conclusion.
Good. Let me set up a specific scenario. You're analyzing an A/B test for a new search ranking algorithm. The overall click-through rate in the treatment group is 20%, in control it's 22%. But when you look by device, mobile shows 14% treatment versus 12% control, treatment is better. Desktop shows 31% treatment versus 28% control, treatment is better again. What's going on, and what do you conclude?
This is exactly Simpson's paradox in an A4GB test context. Within each device segment, treatment outperforms control. But the aggregate flips because the mix of devices across the two groups is imbalanced. I'd guess the treatment group ended up with a much higher proportion of mobile users who have a lower baseline click-through rate than desktop. Mobile traffic is pulling the treatment average down, not because the algorithm is worse on mobile. It's actually better, but because there's more mobile in the treatment bucket. Before I can conclude anything, I need to check for a sample ratio mismatch. If the treatment and control groups were supposed to be 50-50, but mobile users are 80% of treatment and 40% of control, the randomization is broken, and no analysis is trustworthy until that's fixed. If the randomization is sound, and this is just a post-stratification imbalance, the correct answer is to report the device-level estimates and weight them by the actual user population, not the sample composition. The algorithm is genuinely better on both devices. The aggregate is just a product of composition, not performance.
What if you ran the SRM check and the treatment to control ratio is 52-48, which is slightly off but within what some teams call acceptable? Would you proceed?
Honestly, I'd be cautious. Whether 52-48 is acceptable depends on the sample size. With 50,000 users, a deviation that small may be within chance variation. You'd run a chi-square test on the assignment counts to get a p-value on the ratio itself. If that test comes back non-significant, the ratio might just be noise. But if the test says it's statistically significant, I wouldn't proceed with the analysis. Even a small systematic imbalance can bias results when the confounding variable, in this case device type, is strongly correlated with the outcome. The right call is to investigate the assignment mechanism first. Some teams do accept small deviations, but I'd rather flag it and have a conversation than present results from a compromised experiment.
I like the rigor. Let's switch to metric design. Your product team says they want to measure user engagement for a content platform. Think something like a news app. They've asked you to define what engagement means and propose a primary metric. How do you approach this?
Engagement is one of those words that sounds specific, but actually has at least 3 different dimensions. Breadth, meaning how many users engage at all. Depth, meaning how much they do per session. And frequency, meaning how often they come back. I'd want to nail down which dimension the product team actually cares about before proposing a metric. That said, for a news app, I'd argue the most meaningful primary metric is something like articles read to completion per daily active user. Here's why. Session count is terrible for this use case because a crash or a slow load inflates sessions. Raw page views inflate if you show clickbait headlines that get opened and immediately closed. Articles read to completion ties engagement to a genuine value delivery moment. The user got what they came for. It also has a natural connection to advertising revenue, which is usually the business model for news apps. The guardrails I'd add are DAU divided by MAU as a stickiness check and notification opt-in rate as a signal we're not inflating the metric by pestering users into opening the app. I'd also want to validate that articles read to completion in week 1 is actually predictive of D30 retention, because if those two aren't correlated, I need a different metric.
How would you handle the fact that some articles are 200 words and some are 5,000 words? Does completion mean the same thing across both?
That's a really important edge case, and I should have flagged it myself. A 200-word article that gets read to the end in 30 seconds is very different from a 5,000-word long-form piece. If completion is binary and length agnostic, the metric will be dominated by short articles and tell you very little about deep engagement. A better definition would be something like time-adjusted reading depth, measuring what % of the article the user scrolled through, scaled by a reasonable reading speed estimate. Or you could threshold it differently. Maybe 50% scroll depth on short articles and 75% on long ones counts as meaningful engagement. Either way, I'd pilot the metric on a sample of sessions where you also have qualitative feedback to check whether your definition aligns with what users would actually call a satisfying read. Defining the metric in a vacuum and then optimizing it is how you end up with a metric that's gameable and doesn't reflect real value.
Okay, let's do a tricky SQL problem. You have 3 tables, orders, with order underscore ID, customer underscore ID, and amount. You have order underscore items, with item underscore ID, order underscore ID, product underscore ID, and quantity. And you have products, with product underscore ID, name, and price. Write me a query, or reason through it aloud, that returns each customer's total revenue and the number of distinct products they've ordered. The catch: some orders have multiple items, and prices have changed over time, so the products table only has the current price, not the historical one.
Let me think through this carefully before writing anything. The natural instinct is to join all 3 tables and then aggregate. But that's where the trap is. If I join orders to order underscore items, each order fans out into multiple rows, one per item. If I then sum the orders.amount column, I'm summing that amount once per line item, which inflates the total. So I need to keep the aggregation separate and then combine them. I'd approach it in 2 CTEs. The first CTE pulls total revenue per customer directly from the orders table before touching order underscore items. Just sum of amount grouped by customer underscore ID. That's clean, because orders.amount is one row per order. The second CTE joins order underscore items to products to get distinct product counts per customer, grouped by customer underscore ID. I'd use count distinct on product underscore ID here to handle cases where a customer ordered the same product in multiple orders. Then I'd join those 2 CTEs on customer underscore ID to get both measures side by side. On the price point, you mentioned the products table only has current price, so I explicitly would not use products.price to calculate revenue. I'd rely on the amount column in orders, which I'd assume captured the price at time of order. If that assumption is wrong, I need to ask about a price history table or an amount column in order underscore items. That's a question I'd flag to the stakeholder before running the final numbers.
What if there's no amount column in orders? The source system only stored individual item prices in order underscore items. How does your query change?
Then I have to calculate revenue from the item level. I'd compute revenue in a CTE over order underscore items by summing quantity times products dot price, group by order underscore ID, and then by customer underscore ID via the join to orders. The fan-out risk is now on the product side rather than the item side. But since I'm aggregating items to one row per order before joining to orders, that's safe. I'd write it as first CTE aggregates order underscore items join two products into revenue per customer. Second CTE, same join, gives me count distinct product underscore ID per customer. Then join both on customer underscore ID. I'm using current price throughout, which means the revenue figures are current price revenue, not actual historical revenue. I'd put a comment in the code and a note in any report flagging that limitation. It's a meaningful caveat, especially if prices changed significantly.
Last question. The VP of sales comes to you and says, I want a chart for my board presentation showing how much our revenue has grown. She sends you a bar chart where the y-axis starts at 900,000 and goes to 1,020,000. Revenue went from 950,000 to 1,005,000, about a 5.8% increase. She loves the chart because, quote, the bar for this month looks huge compared to last month. How do you handle this?
I'd want to handle this carefully because she's not trying to deceive anyone. She's excited about a real result and she wants to communicate it compellingly. The issue is that the chart encodes a 5.8% improvement as if it was something like 300%. Because bar height is supposed to represent the ratio from 0. When you truncate the y-axis, you break that encoding. A viewer glancing at that slide will take away a growth story that's much larger than what actually happened. And if anyone in that boardroom notices or asks about it later, it creates a credibility problem. I'd go to her directly before the presentation and frame it not as a rules lecture, but as protecting her. Something like, I want to make sure the chart tells the story accurately. Because if a board member asks about the scale, we want to have a good answer. Then I'd offer her a better alternative that still makes the point. A full-scale bar chart with a clear label showing the absolute numbers and a percentage growth callout 5.8% quarter over quarter placed prominently. Or a line chart showing the trend over several months, which would put this period's growth in context and might actually tell a richer story than a two-bar comparison. The growth is real and worth celebrating. The chart just shouldn't make it look like something it isn't.
She pushes back and says the board always uses truncated axis in financial charts and she's not changing it. What do you do?
I'd make one more specific clarification. There is a legitimate use case for non-zero access in line charts, where you're showing variation around a meaningful non-zero baseline, like body temperature or stock price movement. For line charts, that's sometimes defensible and clearly labeled. But for bar charts specifically, the bar's entire height from 0 is what encodes the value. That's the visual grammar of a bar chart. Cutting the baseline on a bar chart is visually deceptive, even if unintentionally. So, I'd acknowledge that I understand it's a common practice. But I'd try once more to offer a compromise. Keep the chart if she prefers, but add a clear axis label that says y-axis starts at 900,000 and add the percentage growth as a text callout directly on the chart. That way the number is transparent and the chart is less likely to mislead. If she still says no after all of that, I've done my job by flagging the risk. I document my recommendation and move on. Ultimately, it's her presentation and her call. But I wouldn't attach my name to analysis that I think misrepresents the data.